Welcome back, computer scientists. Okay, so you should now be on to this section here where we talk about identifying the inputs, processes, and outputs for a problem. So at this stage, we've taken a problem and we've conducted decomposition, abstraction, and we're ready now to create an algorithm design. So in terms of a starting point, and I would suggest this is a good idea. In an exam, you will be asked to write algorithms. And I always think a good starting point is to look at the problem and make a list of the inputs, the outputs, and then any processes that you would need in between. Generally speaking, it's very easy to identify what inputs are going to be needed. The problem might say, this program will only allow people over the age of 16 to use it. Okay, so an input you'd look for is age. So you could compare the age and decide whether or not that person could use it or not. So inputs are fairly easy to identify within a problem, and just make a list of them, give them a useful name, a good variable name that's going to be meaningful. Okay, and remember your rules on naming variables. Variables, they don't begin with a capital letter, they don't contain spaces, they can't begin with a number, and they can't be the same. You can't have two variables with the same name, and you can't choose a variable name that is already within a library, something like print, okay, or input. So identifying those inputs is a really key ingredient for writing an algorithm. And then also the outputs, what is going to be the end product? Is it just going to be a message? Is it going to be the results of a process? Okay, so the inputs and outputs are fairly easy to spot. The process is less easy, but again, you kind of look at what that person's been asked to input into the system, and then what is the program going to do based on that input. And that process might be a comparison, it might be some kind of calculation. And that comes with practice. This is, let me just stress this, this is not easy. You have chosen a challenging qualification. So this is not easy, and we're covering it in year 9, but you'll be looking at again in year 10 and again in year 11. So these are things that we will be looking at regularly. It's important that we keep testing ourselves on it. So I'm going to test you, this next section tests you on that understanding. And please don't be, upset if you don't do well on this. This is a tough one. So look at this exam. River levels are regularly checked by the Environmental Agency, and sluice gates, I think that's overflow, are opened or closed automatically to control the flow of water. What would be an input for this scenario? So you've got to think, right, I've got to write the program. You're not building the gates, and you're not digging a great big hole in the river or building something next to a river. You are just dealing with the program that's going to operate all the machinery involved. Okay, so what inputs need to be added to the system so we can make decisions on whether or not to open these gates? So levels compared with maximum minimum dispersal levels held in system, river levels at key points, or a motor opening. So a motor opening is not an input or output, it's a process. Yeah. What's levels compared with minimum maximum permissible levels held in a system? That would be validation. What we're looking for are inputs at the levels at key points. So that would be kind of answer, that would be the answer for that one. River levels are regularly checked. Sluice gates open and close automatically. What would be the process for this scenario? So we have taken our input, which is the river level at key points. So that might be, 3 or 4 times a day. Yeah. So we're taking those river levels. That's an input. What we're after now is a process. Okay, so I don't know if I said this right last time, but the gates opening, that's an output. Yeah, that's what that's going to be the result of our program. Okay, it's going to either open or close those gates. So the process, it would need to compare. It would look at that level and it would compare it with maximum and minimum permissible levels. Okay, if it's below minimum, we're going to if it's above maximum levels, we might need to open the gates to release some of that water. Okay, if it's dropping below that level, we need to close the gates in order to bring that level back up. So that would be a process. What would be an output? So we've just talked about those. So obviously the gates opening or closing is going to be the output from that system. Okay. So you might think, oh, he's given us all the answers. And that's right, I am. I'm doing that to make sure that, you know, you are watching these videos. If you watch these videos, there's absolutely no reason why you can't get these first 3 questions correct. This is a little bit more challenging because I am not going to go through the answers with you. Okay. There is one that I might just mention. Just on this last one. Exam results for a group of students are entered and validated. Validated means that we are checking that the inputs match a certain criteria. Okay. So if you see the word validation, here's one as well. Yeah. Validation means we are checking that the input entered matches a certain criteria. And that will help hopefully with some of your answers. Okay. Once again, good luck.